Welcome back. Today we're looking at exponential transformations, the domain and range of functions. So for the transformations, we're looking at how we can take our base function. So this is what y equals any number to the x might look like. So y equals ab to the x. Note that for our base function, that our point here at 0, 1 is one of the anchor points here. We don't have a vertex for this type of function, but the base function does pass through the point 0, 1 unless we mess around with the a. All right, so let's kind of look at ways that we can transform these functions. So we're going to graph negative 8/3 to the x today. So we're just going to be plugging in all these x values in to our function to find our y's. It's always helpful, especially if we don't know what the graph is going to look like, to make a table so we have it on the left hand side. We're going to be plugging all our x's in to our function and finding what our y is. Remember, so the first thing we're going to do is plug in our -2. Remember, the negative means that we're going to reciprocate. So we can do that first. And then the square means we're going to multiply it by itself, right? So in this case, we're going to do 3 squared is 9. 8 squared is 64. And then we have the negative. So we're going to have negative 9 over 64. We're going to do the same thing with our 1. So our -1, excuse me. So 8/3 to the -1 power means that we're going to reciprocate, and anything to the first power is itself, so -3/8. The 0 power is pretty easy. Anything to the 0 power is 1, so we have -1. And then when we look at the next one, we're just going to be doing -8/3 to the first, which is -8/3. And then the same thing with R2, so we're going to have -8/3 squared, and then we're just squaring the top and bottom, so it's going to be -64/9. All right, so you're going to just go in Alex. We're looking for this symbol here. You're going to press that button and you're going to plug in all these different points. So if we're looking, and we're just going to eyeball it here because I definitely don't know exactly where 9/64 is, but I know it's pretty close to the x-axis. And 3/8 is a little bit further from the x-axis. 0 and it hits -1. That's pretty straightforward. And then 1 is 8/3, so that's pretty big. And then 2 is -64/9, which is pretty big too. So we see that our function looks kind of like the function that we started off with, right? Our base function, except for 2 things. It flipped over the x-axis. Right, so this thing made it flip over the x-axis. And then the and then our point changed, right? Because it started off at 0, 1, and then it flipped down to 0, -1. And then the 8/3 made it a little bit different, but for the most part, it's very similar to the first graph. It just flipped it over the x-axis with a negative sign. Right, which is not too different from if we had a parabola, right? So our base parabola looks like this. If we say we're looking for the graph of -x², all that does, that negative sign in front flips it over the x-axis. Same idea for our exponential graphs. All right, so this next one is asking us to translate this function. So this is the y equals 1/4 x. They're giving us the graph of that function. It's saying, all right, translate it. So with your mouse or your cursor, click on it, drag it to where it would be for this function. Now this one isn't too bad either once you get the idea of how we're moving these things. So just like when we're talking about an algebra, right? We can view this thing, the exponent, as the parentheses part. So if we're looking in here, our x minus 3, when we're talking about an algebra, it's kind of strange in this sense because anything in the parentheses, if it's plus, it actually goes to the left, and if it's minus, it goes to the right. And it's because the starting form is that x minus h, right? So another way that it's written in algebra would be like y equals f of x minus h plus k. So whatever your function is, in this case we're using an exponential function, right? So this is the part that's the exponential part with the x. We're looking in here, anything to the right, anything minus goes to the right, anything plus goes to the left. So what we're going to note here is that we have minus 3, so we're going to say right 3. And again, that's really weird that minus goes to the right and plus goes to the left. So you might either want to remember it or just remember that we have this negative sign or minus sign inside of our parentheses always. So we need to figure out if it's a minus, what we're going to do with it. So the minus 3 means we're going right 3. The plus 2 outside, this plus k, right, tells us up and down. So it's going to go up 2. So whatever's outside the parentheses, plus means up, minus means down. All right, so we're just going to take this, and it's easy to go from this point and shift the point. So we're going to go up 2, and then right 3, and that will be our new point. So if we go up 2 from that point, we get 3, and if we go right 3, we get 3. So we're at 3, 3, and we're going to draw this exact same. Well, you don't have to draw it in your work because all you're doing is dragging it, but it should look kind of like that. All right, so just make sure you drag this point right 3 and up 2 so that you get to the point 3, 3, and then it should be good. So just another recap in case you guys didn't catch this earlier. So we're looking at this number up in here. So let's say this time we had x plus 4. So let's do, it doesn't matter what this number on the bottom is. So let's say 2 and then minus 1. Okay, so we treat this as if we're the parentheses of our function. The inside, the plus means left and the minus means right. It's vice versa. It's flip-flopped from your usual thinking. So if we're looking at this function, we take the function y equals 2x, right? And the difference between y equals 2x and the function that we have here is that we have moved left because it's a plus 4 units. And then the minus on the outside one is down 1. So you just take this point, 0, 1, wherever it's at, grab that point, shift that point left 4 and down 1, and then your graph should be perfect. All right, it's going to take some time to get used to. It's something that we talk about extensively in transformations for Algebra 2. It's going to come up again, so try your best to understand it now. I know exponential is kind of a weird way to do it, but the more you do, the easier it gets, and the more you see it popping up, the more familiar we'll become with that concept. Okay, and the last thing that we're asked to do today is find the domain and range. Remember, domain means all the x values, and then the range means all the y values for the function. All right, so for any exponential function, So we have one drawn here, right? The arrows, the exponential functions, when we're talking about our domain, the arrows mean it's continuing on in this direction and down forever, right? This arrow means it's continuing this way forever. Notice that we have this asymptote, y equals -1. So what happens there is it doesn't cross over that line. All right, so but for domain, because the x values, we can plug in any x value into our function and get a number out. So our domain is going to be all real numbers for any exponential function. Now our range is a little different. So for our range, notice that this one's going to go downwards forever, but the top of it is going to be y equals -1. We're never going to actually hit that value. It's going to stay below it. It's going to get ever and ever closer to -1, but it's never going to reach -1. Even if we went towards the positive side all the way to infinity, we'd never actually hit -1. So our range is going to be y, because we said the range deals with the y values, is always going to be less than -1. It's never going to be greater. Okay, so that's how you find your domain and range. I'm not sure if you guys talked a little bit about domain and range in Algebra 1 when you talked about parabolas and stuff, but it's a good place to start thinking about it. It's not something that's, well, it is important when you're thinking about applications in real life, because the maximum value that you could get and the minimum value you could get is important in that sense, but it's just something that kind of comes up over and over and over again in math. It's not the most important concept all the time, but it's something that happens over and over again. It's always good to keep in mind your domain and ranges. So it's a good starting point. All right, that's it. Make sure you have your notes taken down. Make sure you have any side notes that you need for reminders for yourself. And make sure you have any questions. If you have any questions, you write those down. And then I can help you guys out on next class. All right? Good job.